Hi, welcome to my channel Mathematics Made Easy by Mary MJ. Today I am discussing class 11, chapter 7, Permutations and Combinations. It's a different kind of chapter which is applicable in a day-to-day life. So let me introduce the chapter. Suppose you have a suitcase with a number lock. So this is the number lock of the suitcase, and the number lock has 4 wheels labeled from 0 to 9. Each wheels is labeled from 0 to 9, and the lock can be opened if 4 specific digits are arranged in a particular sequence without no repetition. So there should be a particular sequence in order to open the lock. Then only it can be opened. And what happened is that I forgot that specific sequence of digits. So which is that pattern I forgot. But only thing I remember is the first one should be 7. First lock, the number lock on the first wheel should be 7. So in order to open the lock, so many sequences we can make with the remaining 3 wheels. So these 3 wheels we can arrange in a lot of different ways. Only thing is that I know the first digit, whereas the 3 remaining digits I don't know, but we know that it is in a particular sequence. So what we will do is we start listing all possible arrangements. We start listing out all possible arrangement of the remaining digits taken 3 at a time. So all the remaining 9 digits we will arrange it in all the possible ways in order to open the lock. So it should be in some particular sequence also. But we know that this method is very tedious method, because how to arrange all these to find out the correct number pattern is very difficult. So for all these things we learn some basic techniques, counting techniques, so which enable us to answer those type of questions. How to make such a pattern, how many possible ways are there for arranging, these all we study here. In this chapter we are going to study some basic counting techniques which enable us to answer this question without actually listing out all the 3-digit arrangements. That's quite nice, right? So before stepping out we shall examine the fundamental principle of these learning techniques. That is, we are moving on to fundamental principle of counting. Fundamental principle of counting. So what do you mean by fundamental principle of counting? That also I'll explain through an example. So a person having 3 different color shirts, 3 different color pants. So let the person's name, let it be Ravi. Ravi is having 3 pants and 2 shirts. All the 3 pants are of different color, and he's having 1 white pant, 1 red pant and 1 black pant. Whereas he's having 2 different color shirts. He's having red shirt as well as green shirt. 2 different color shirts. Which all different ways he can wear this? He can wear white pant of white color along with shirt of red color, or he can wear pant of white color with shirt of green color. Anyway it is possible, right? Then or he can wear pant of red color with shirt of red color. Quite nice. Then or he can wear pant of red color with shirt of green color, or pant of black color with shirt of red color, or pant of black color with shirt of green color. Just see how many different ways he can wear the pant and shirt. That is, here this one combination, 2, 3, 4, 5 and 6 different combination. So instead of listing out all these combinations, we can say that according to fundamental principle of counting, if 3 is having 3 different pants and 2 different shirt, there will be 3 into 2 different ways of selection, of arrangement, of wearing. That is, 3 into 2 is 6 different ways he can wear this pant and shirt. And this type of counting we call it as fundamental principle of counting or multiplication principle. So what is actually fundamental principle of counting? If an event can occur, if an event can occur in m different ways, following which another event can occur in n different ways. So first one is occurring in m different ways, following which another event can occur in n different ways, then the total number of occurrence of the events in the given order is m into n. So here in this example, we were having Ravi was having 3 pants and 2 shirts, and he could wear this in 3 into 2 different ways. So that's called the fundamental principle of counting. So we can do few example questions related to this fundamental principle of counting. So first question, find the number of 4-letter words. Find the number of 4-letter words with or without meaning, with or without meaning, which can be formed out of the letters of the word rose, where the repetition of the letters is not allowed, where the repetition of the letters is not allowed. So find the number of 4-letter words with or without meaning which can be formed out of the letters of the word rose where repetition of the letters is not allowed. So we have to form 4-letter words and given 4 letters also. So repetition is not allowed. So first space, this is the first place. Out of these 4 letters R-O-S-E, we can allot any one letter here. Out of the 4, any one. So here we can arrange out of that 4, any one can be allotted in the first place, followed by, so 1 already allotted here. Remaining how many will be there? 3 letters will be there. Out of the 3, we can arrange 1 over here from the 3. So since repetition is not allowed, So out of the 3 only 1 you can arrange, and you cannot take that which is allotted here in the first 2 places, again you cannot take. So in the next one there will be only 2 possibilities, because out of the 4, 1 we put it here, 1 we arranged here. Out of the, so 1 is already finished, we can't take that again because repetition of the letters is not allowed. Then remaining 3 letters are there. Out of the 3 you can keep 1 over here. So again only remaining 2 are there. Out of the 2 any 1 can be allotted here. So out of the 2 any 1 here. Remaining only 1 letter is there that can be allotted here. So by fundamental principle of counting, the number of ways of arrangement, the number of ways, required number of words are required number of words is equal to 4 into 3 into 2 into 1, which is equal to 12 into 2 is 24. Number of required number of words equal to 24. So there are 4 ways of there are 4 ways, 4 vacant places, and the first place can be filled in 4 different ways by any one of the 4 letters. So how to write in words? So we can write here, there are 4 vacant places and 4 letters to fill. 4 letters to fill. And repetition is not allowed. Repetition is not allowed. Hence the first place can be filled. Hence the first place can be filled in 4 different ways. 4 different ways by any one of the 4 letters of R, O, S and E. Same way or similarly, second place can be filled. Second place can be filled in 3 different ways by any one of the 3 letters, because already 1 is allotted as the first letter. Then etc. Same way it is going on. Okay. So thus by fundamental principle of counting, the required number of words, is equal to 4 into 3 into 2 into 1, that's equal to 24. Suppose in the same question, if they are asking repetition is allowed, here repetition is not allowed. If repetition is allowed, then each places can be repeated, no? So what you can, first place can be filled in any one of the 4, second place also, once if you are using there also, again we can use. So again out of the 4 any one can be allotted for the second place. Same way third place also we can allot any of the out of that 4. So fourth place also. So but if repetition is allowed, 4 into 4 into 4 into 4, which is equal to 256 different ways. So that's a different difference. That is, if repetition is allowed, if repetition is not allowed. So repetition is allowed means we can consider whichever we have taken it already, that again we can use. That is the difference. Now another question. Given 4 flags of different colors. Given 4 flags of different colors. How many different signals? How many different signals can be generated if a signal requires the use of 2 flags, one below the other, one below the other. Given 4 flags of different colors, how many different signals can be generated if a signal requires the use of 2 flags, one below the other? So like this way we have to arrange the flags. For making a signal we need 2 flags, but both should be different. That means once we are using one color here, we cannot use the same color here. 4 flags of different colors. So 4 different colors are there. How many different signals can be generated if a signal requires the use of 2 flags, one below the other? So in order to make a signal, we need 2 flags. So here we can take any one of the 4 flags. In 4 different ways we can take, followed by the second one can be taken in 3 different ways. One already allotted here. Out of the remaining we can take any 3 for the second place. So by fundamental principle of counting, the required number of signals, is equal to 4 into 3, that's equal to 12. Now next one. How many 2-digit even numbers? How many 2-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 if the digits can be repeated? If the digits can be repeated. So how many 2-digit even numbers? We need to make 2-digit even numbers from the digit 1, 2, 3, 4, 5 if digits can be repeated. So repetition is allowed. So even number means the last number should be even, then only it can be even number. So then the only possibility is either 2 or 4 here last. Here for the last term, last digit, it should be either 2 or 4 because we are finding out 2-digit even numbers. So out of this 5 I can take only 2, any 2 here. From those 2 only I can select a number here. Out of the 2, either 2 or 4. These are the only possibilities for the last digit because we need even numbers. So the last digit can be selected out of these 2. Any one can be allotted here. Whereas since repetition of the digits are allowed, repetition is allowed, so what can you do? The first 2 digit can be any of these 5. So any 5 can be, from this any 5 I can take a number here because repetition is allowed. So Here why only 2? Because we need even number. So here only 2 even number. Out of that 2 I can allot a number here. So by fundamental principle of counting, then the required number of 2 digits. Required number of 2-digit even numbers. 2-digit even numbers is equal to 5 into 2, which is equal to 10. Now we'll move on to next exercise questions. Exercise 7.1. First question, how many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that first sub question, repetition of the digits is allowed. Repetition of the digits is allowed. Second sub question, repetition of the digits is not allowed. So the question is, we have to make 3-digit numbers. So 3-digit numbers we are going to make. Okay. In the first case, repetition is allowed. So the first digit can be the first digit D1. Let this be D1, D2 and D3. D1 can be arranged. D1 can be arranged in 5 ways. Second digit D2 can be arranged in 5 ways. Third digit D3 can be arranged in 5 ways. Therefore, total number of 3-digit numbers. In the first case, I am telling about the first sub question. Total number of 3-digit numbers is equal to 5 into 5 into 5, which is equal to 125. So in the second sub question, D1 can be arranged in 5 ways. D2 can be arranged in 4 ways. D3 can be arranged in 3 ways. Therefore, total number of 3-digit numbers is equal to, according to fundamental principle of counting, 5 into 4 into 3, that's equal to 60. Now the second question, exercise question number 2. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated. So it's told that digits can be repeated. We need to make 3-digit numbers. So we can write here this 3 digits are there. Just let it be D1, D2 and D3. So since we need to find 3-digit numbers, how many 3-digit numbers? Always the even numbers end with the last number should be an even number. So it is given here from the digits 1, 2, 3, 4, 5, 6. So what can, which all we can take for D1? D1 is the last digit here. So D1 can be arranged. D1 can be arranged by 2, 4 or 6. Only even numbers can be arranged as the last digit, third digit. So from 2, 4 or 6 we can take one digit as the last digit. Then what about D2 and D3? So here we can see that out of these three, any one will be allotted as D1. So D1 can be arranged in three different ways. Now D2, what about D2? There are 6 numbers here. D2 can be arranged in, repetition is allowed here. So D2 can be arranged in 6 ways. Also D3 also can be arranged in 6 ways. Therefore total number of 3-digit numbers. Therefore total number of 3-digit numbers is equal to 6 into 6 into 3, which is equal to 108. Next one. Question number 3. How many 4-letter codes? How many 4-letter codes can be formed using the first 10 letters? Using the first 10 letters of the English alphabet. Of the English alphabet, if no letter can be repeated. If no letter can be repeated. So we need to make a 4-letter code. Let it be L1, L2, L3 and L4. So from using the first 10 letters of the English alphabet. So and it is told that no letter can be repeated. So L1 can be arranged. L1 can be arranged in 10 different ways. In 10 ways. So here I can take any one of the 10. Whereas since repetition is not allowed, L2 can be arranged in only 9 ways, whereas L3 can be arranged in 8 ways, followed which L4 can be arranged in 7 ways. Therefore, total number of 4-letter code is 10 into 9 into 8 into 7, which is equal to 5040. Now question number 4. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once. So it is told to make a 5-digit telephone number. We have to make a 5-digit telephone number and its first 2 digit, it should be 67. So only we have to find out what are the remaining 3. and we have to use the digits from 0 to 9, and no digit appears more than once. So out of the 0 to 9, already 2 numbers total, there are 10 numbers 0 to 9. Out of that, 2 numbers already we allotted here. So we cannot take 6 and 7 again. That means out of the 10, 2 already arranged here. So again only 8 more digits are there. So this let it be D1, D2 and D3. D1 can be arranged. D1 can be arranged in 8 ways. Followed which D2 can be arranged in 7 ways and D3 can be arranged in 6 ways. Therefore, by fundamental principle of counting, number of ways is equal to 8 into 7 into 6, which is equal to 336. Now, next one. Question number 5. A coin is tossed. A coin is tossed 3 times and the outcomes are recorded. And the outcomes are recorded. How many possible outcomes are there? So a coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? So each coin when tossing, we are having 2 outcomes, either head or tail. So like that way 3 coins are tossed, or a coin is tossed 3 times. So by fundamental principle of counting, we have 2 into 2 into 2. In each throw, the number of ways of getting different outcome is 2. So given that the coin is tossed 3 times, so number of possible outcome is 2 into 2 into 2, that's equal to 8 outcomes. Now next one, question number 6. Given 5 flags of different colors, how many different signals can be generated if each signal requires the use of 2 flags, one below the other. So one flag, the second flag is below this. So 2 flags are there. So 5 different flags, 5 flags of different colors. How many different signals can be generated if each signal requires the use of 2 flags, one below the other? So there are 5 different flags. So first flag, out of the 5 we can select any one as the first flag here. Then what about here? So the second flag, remaining only 4 flags are remaining. Out of that any one we can allot here. Therefore by fundamental principle of counting, number of ways is equal to 5 into 4, that's equal to 20 different ways. So that's all from the first exercise. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.